All right, here are solutions for perfect problem 6 for Math 243. So what's going on here? I claim that I have a drug that makes people run further. Okay. I know that the average person can run 4 miles. Sounds like a population average. You'd think it should be mu, but we actually want to use mu for something else. So we're going to call it mu naught. But in a random sample of 80 people, sample size, we use n to represent that. That were taking my drug, the average person ran 4.2 miles. This is a sample average. Use X bar for that. With a standard deviation of 1.2 miles. Note that that's a sample standard deviation, so we use S for that. Test the claim that my drug increases the distance someone can run with 95% confidence. That'll be important. That'll tell us that alpha is equal to 0.05. Using both the p-value and the classical methods. Okay, so first let's do p-value. First step when we're doing this hypothesis testing is we're going to state the null and alternative hypothesis. Null hypothesis, you can write capital H with a little 0 next to it. Alternative hypothesis, capital H with either an A or a 1 next to it. I think our book uses a 1. And what your null and alternative hypothesis will do is they'll always compare mu to this thing mu naught. So mu is the population average for all people if all people were taking my drug. So my null hypothesis is kind of that my drug doesn't do anything. It's that mu is the exact same as mu naught here. However, my alternative hypothesis is my claim, somewhere in here, I claim that the drug increases the distance someone can run. In other words, my alternative hypothesis is that mu is greater than 4. Because I have greater than here, this is what's called a right-tailed test. If this were less than 4, it would be a left-tailed test. If this were does not equal 4, it would be a two-tailed test. So step 1, over the p-value method, is just state your null and alternative hypothesis. Done. Step 2, describe and justify the shape, center, and spread of the average vertical leap. Vertical leap? I'm going to have to fix that. We're not talking about vertical leap. Describe, justify the shape, center, and spread of the distribution. I'll make sure to fix that on your guys' version. Okay, shape. Hopefully it'll end up being approximately normal. It will. Approximately normal, our criteria for it becoming approximately normal, this is the central limit theorem. It's because n, our sample size, is greater than or equal to 30. Our sample size is 80 here. 80 is greater than or equal to 30. We should also note that this is a t distribution, and the reason it's a t distribution is because sigma is unknown. So later on, when I use my calculator, I'm not going to do a z test. I'm going to use a t test. Shape, center. So the logic that you follow when you're doing these tests is you start by assuming the null hypothesis is true. So really this is the center for mu. However, I'm going to assume that the null hypothesis is true, that mu equals 4. So my center will be mu naught, which is equal to 4. And my spread, the symbol I will use for that is sigma sub x bar, because it's the standard deviation of my sampling distribution. And what that is s divided by the square root of n. S given to us in the problem as 1.2. Yeah, 1.2. And n is 80. So my spread is 1.2 divided by the square root of 80. You can figure out what that number is if you want. You don't have to. And then third, I think these were A, B, C, D. That probably, whatever. A, B, C. Part C under the p-value says sketch a distribution showing the test statistic and the p-value. Okay, so draw a picture. I want my picture to be approximately normal because it says shape is approximately normal. I want the center to be 4. And what I got to do is figure out where to put my test statistic, where to put this 4.2. So 4.2 is out here somewhere. However, I don't want to know I want to convert these all into z-scores. So this value of 4 has a z-score of 0. To figure out what the z-score for 4.2 here is, I have to use my calculator. So finally over here to my calculator, if you hit stat and then go over to tests, you'll see t-test. T-test because this is a t distribution. Data or statistics. I don't have the data itself, I just have statistics about the data. What is mu naught? Mu naught was equal to 40. Right? They gave us that in the problem here. No, it wasn't. It was equal to 4. X bar was equal to 4.2. The standard deviation, note it's a sample standard deviation, is 1.2. N, how many people in my sample? Looks like there are 80. And now what it wants to know is, what is your alternative hypothesis? My alternative hypothesis is that mu is greater than mu naught here. So I want mu is greater than mu naught. And now you can either go to calculate or draw. Either way will give you all the information you need. Maybe I'll do draw. No, I'm going to do, well, doesn't matter. Draw. See what happens. What it does if I do draw is it draws this little picture for me. Eventually, it does it very slowly for some reason. But there we go. Now it's shading in this region above 4.2. What it says is the test statistic corresponding with this 4.2 is 1.49. And then it tells me that the p-value, the area above 1.49, is equal to 0.07. So when it asked me to sketch a distribution showing the test statistic and the p-value, here's the test statistic, here's the p-value. Part D says state your conclusion. When you're drawing a conclusion based on the p-value test, all you got to do is compare your p-value and alpha. Alpha was 0.05. Our p-value is greater than alpha because my p-value is greater than alpha. There is not. Let's see, I know what I'm going to do here. I'm going to write this down here. There is not sufficient evidence to reject the null hypothesis. So we're not saying that the null hypothesis is true. We're just saying there's not enough evidence to conclude that it's false. We are not saying that my drug does not work. We're just saying there's not enough evidence to conclude that it does work. All right, now we got to do even more. That's the end of the p-value test. We got to do the classical method test. The good news is we can reuse a lot of this stuff. Part A is the exact same. Part B is the exact same. For part C, my picture is going to look slightly different. So what I got to do for part C, it's still going to be approximately normal. Pretty good looking picture there. Center is still going to be 4, which still has a z-score or a t-score of 0. Except now, what it wants me to do is show my critical values, or value. I guess it's just value in this case, alpha in the test statistic. Okay, so the way you figure out the critical value is you set up what's called a rejection region. You say, okay, there's some area out here. The total area of this rejection region is always equal to alpha, so it's 0.05. So this is my rejection region. What I want to do is figure out what t-score, what test statistic would correspond with the endpoint of this rejection region. If you're lucky, your calculator has a function that does that. This one doesn't. If you go under distributions, you might have something here that says inverse t. If you do, you can use that. But if you don't, like me, you have to use some tables that look like this. And this gives me the t value on the inside here for a given probability. So note that the shaded area, I want that to be 0.05. So that's this column right here. And then over here I have degrees of freedom. Degrees of freedom is always 1 less than n. So n is equal to 80. That means I have 79 degrees of freedom. So I go down here, I'm looking for, I don't have a 79 row. If I did, I'd use it. 80 is the closest I have to 79, but really I'm looking for 79. I don't have 79, so I'll use 80. And I get this 1.664. So what that tells me is that this value right here is 1.664. This is a t value here. Now what you want to do is calculate your test statistic. We already calculated that 1.49. What I want you to note is that 1.49 is not in the rejection region. Right? The 1.49 is less than this 1.6. Let me draw this better. This 1.49 right here is less than 1.664. So my test statistic is not in the rejection region. So this test statistic, which corresponds with 4.2 miles, 1.49, same thing I have over here, it's not in my rejection region. So as far as my conclusion, I say because my test statistic, which was 1.49, is not in the rejection region, then I draw this same conclusion. Because it's not in the rejection region, there is not sufficient evidence to reject the null hypothesis. So same conclusion no matter which method you use, just two different ways to go about it. Classical used to be a little bit easier, but with the advent of these calculators, p-value is really a lot easier. But either way, you do it whichever way makes sense. On this quiz, I'll have you do it both ways, but generally I'll let you choose which way you want to do stuff. So that's the end of this, I guess not quiz, but perfect problem.